So we're working on section 5.3 today. Lots of algebra in this section. And these three properties you need to memorize. Add them to your list of properties from last time. And so we'll just start. And some of the things these properties are needed for, what we do is we rewrite them. If we have a product, we can break it apart and possibly simplify. But when we get to equations, which is the next section, you need to have one logarithm. So we will go backwards and put them back together if they're separate, so that we only have one log. So that's kind of what you're going to use this for. All right, so question 1 is going to go with the first property because this is the log of a product. And so we just write it, log base 3 of 5 times 8 is the log base 3 of 5 plus the log base 3 of 8. And you have to look and see if these will simplify. These are not going to simplify. You cannot rewrite the 5 in terms of 3 to a power, nor the 8. Question 2 I skipped. It's very similar. Question 3. You have the natural log of a product, and we're going to have one other property on this one. So we'll break it apart into the sum of the logs. So the ln of e to the 4th plus the ln of v, and on the ln of e to the 4th, we can use the last one and take the 4 down. So we get 4 ln of e. Remember, the ln of e is 1 from our properties from last time. So this piece ends up giving us 4. So 4 plus the natural log of v, and they probably want parentheses there. I don't think they mark us off. They just kind of force them to go on. Right, we did pick 4. So we have common log of 100y. So this is the log of a product. So we'll take the log of 100 plus the log of y. And this one you can simplify. Remember, this is log base 10. You can rewrite 100 as 10 to a power. So it is 10 squared. And then our answer to that piece is 2. You can use that property and just take the 2, or you can take it down, and then this piece would be 1. 2 times 1 is 2. So either way there. So our answer to this is 2. This one will not simplify.
Quick question.
Yes.
On number 3, when you had written the LNE, so that is like, it's like E with the E on there, like together, which makes it 1, but like they're not trying to, like that's not them like trying to confuse us by putting, because I know like sometimes they'll put like the 10 at the bottom of the log, and my brain thinks they're trying to like add something on purpose, like to confuse me.
They just want to check that you do know that it is. This one, you're actually taking the natural log of e. It is base e, but they just didn't put it on there. So it's automatically an e down here.
Okay, so and would it be the same thing with the with like log 10? It would be the same thing like that?
Yes, it would. If they write log 10 and they don't have a base, it's automatically a 10.
Okay.
And you
And
can
then that
you
and that
can
turns
write it
into
on if it
1.
helps you to make it clear. Sometimes it makes it clearer if you write it on.
Okay. Yeah, 'cause I think I was getting confused at which ones turn into 1 because I'll see it with the E and sometimes without. So that's where I'm getting a little thrown off.
And there, one of the properties was just ln of e equals 1. So you could also remember that one, or you can put it
Okay.
on there and work it out.
Thank you.
You're welcome. All right, so we finished 4. I did pick 5 because this goes to the next property. You have the log of a quotient. Quotient means something is divided. And I counted this one earlier, and it's 6 zeros if I'm not mistaken. 1, 2, 3, 4, 5, 6. It's hard to see, hard for me to see. 1, 2, 3, 4, 5, 6 over x. So the log of a quotient is a subtraction. It's a difference, and I kind of crammed that together. I'm going to bring it down here. Sorry about that. All right, so we have the log of this minus the log of x. These are both automatically base 10, and I'm going to put the 10 on this one because I can clean this up, right? And any power here or number here that is 1 with a bunch of zeros is a power of 10. This is equal to 10 to the 6th. Has 6 zeros, so 10 to the 6th power. So we could write it as 10 to the 6th, and then our answer to that piece is 6. Right? So you can take it from there, or you can use the other property and bring it down. 6 times 1 is 6. It doesn't matter which property you use. You get a 6 for that piece, and the other one there is no simplifying you can do. Yes, you guys stop me if you have any question. And if you're not sure about here, this 10 to a power, just play on your calculator and check it. Right, so if I do 10 to the 6th, that gives me 6 zeros, so that's the right one.
So the second one on there, that log y, it's technically log 10 to the y, correct?
Yes.
Or log 10y. Okay.
Yes.
All right, just making sure. Thank you.
And this one is log base 10 of x.
Sorry, just one more question. So when
okay.
we see that, like if I see like a log of like how this one's the log of 1,000,000, that would be like it's kind of like a hint since 10 is like could be a root of that. It's kind of like a hint of like that's going to equal a whole number.
Yes.
Thank you.
You're welcome. Somebody else probably has the same question. So please ask anytime. So the log base 5 of 5 over t. This one is pretty easy. It does simplify a little bit. So this is a quotient, so it will be a difference. So the log base 5 of 5 minus log base 5 of t. And this one will clean up, and that just gives you 1. And nothing you can do on this one. You do have to put the base on there if it's not 10 on the log. All right, 7 I'm going to skip, very similar for you guys. 8 we can do. Right, now we're working natural log. Right, and so this one is also a quotient, so it will be the difference of the logs. So natural log of e to the -3 minus natural log of y. This one is going to clean up. You can either use the property to take this down. So -3 times the ln of e. Or you can put your base e here and then it's equal to -3. Whichever clicks better for you. This is 1 times -3, which is -3. This one, nothing else you can do.
So then same thing, once we open it up, same thing with the ln and the e. When we see the ln and the e, it's a 1, and then if it's a 10 with a log, then it's a 1?
Yes.
Okay.
So number 9 starts with our third property that I had listed, and this one will fit here. It's short. So some of these will be pretty fast for you to do. And this one was the third property. So you have a log of something to a power. Take the power down out in front. So this is equal to 11 times the log base 3 of v. So we have the log base 10, and they put the 10 on there. They didn't have to, but they did. Of the 6th root of x over 100. And so this will be a subtract. And also we're going to change the radical to the rational exponent form, which is x to the 1/6. Right, I'm going to go down to write this one. So I have log base 10 of x to the 1/6 minus log base 10 of 100. Right, on this one, the exponent will come down. So we have 1/6 times the log base 10 of x minus, this one will clean up because we can rewrite this as 10 squared. And then the answer is 2. These are the same, so the answer is 2. And it really should accept your answer whether you put that base on there or not. And they put it just because it was in the problem originally. We'll get to one and I'll type it in just so you can see the right buttons. Sorry, I haven't typed any in today. I'm not going to type this one in. All right, but we will work it. So we have the log base 4 of a quotient and this one also has a product in it and it has a radical. When you have one of these with multiple things like that, anything that is on the numerator is going to have a plus in front of it. Anything that's on the denominator is going to have a minus in front of it. If you just remember that, it will help you. So I'm going to go ahead and do log base 4 of x to the 6th plus log base 4 of z to the 14th. Now it's going to be minus log base 4, and we'll leave it the root here, but then we're going to change it. All right, so that's my first step. My 6 needs to come down on this piece. So I get 6 log base 4 of x. Right, on the next one, your 14 needs to come down. So we have plus 14 log base 4 of z. And then we have minus log base 4. We're going to keep this in parentheses because it has more than one piece. W plus 10 to the 1/7. And the only thing I have left to do is I have to bring the 1/7 down in front of this log. So everything else is good. Alright, so 6 log base 4 of x plus 14 log base 4 of z minus 1/7 log base 4 of w plus 10. I skipped 13. So now we're going to go backwards. The word condense is a clue, and when you're going to go backwards, you want 1 log at the end. So I have log base 8 of 4 plus log base 8 of 16. So we're going to use the property backwards. And so we have a sum of logs that's equal to the log of the product. Now, if we work 4 times 16 out, this gives us 64. And 64 can be written as 8 to a power. It is 8 squared. So the answer on this one is going to be 2. Now, sometimes when you multiply these out, it doesn't give something that you could write in terms of this. So sometimes you might just have to leave what was there. Let's look at 15. All right, so we have the log base 2 of 36 minus the log base 2 of 9. We are condensing, so we're putting it back together. We're going to write log 1 time. And this one is a difference, so it is a quotient. So it is 36 divided by 9. 9 goes evenly into 36. It goes 4 times. And 4 is a number that you can rewrite as 2 to a power. It is 2 squared. And these are the same, so the answer is 2. So that is one that would simplify. Alright, this one has both. So we're working with natural log of 68 minus natural log of 4 plus natural log of 14. So the ones with the plus are going to be the product, and the minus will be a quotient part. So we're going to have 1 log. So the natural log of 68 times 14 over 4. And so we'll get our calculator to have a little help with this. And 68 times 14 is 952. And then we'll just see if it will divide by 4 evenly. And it does. So we have the ln of 238. You cannot rewrite that as e to a power. So you're going to leave it there at 238. All right, 17 is a nice fast one. We have 12 times the ln of y. And so if you have a coefficient out in front, remember that's an exponent in the other form. So we have to put the 12 back in. And this gives us the natural log of y to the 12. Good. All right, 18 I skipped. 19, we'll see how this one goes. So we have 20 log base 5 of y plus 18 log base 5 of z. And so first you will need to put the exponents back on, and then you will need to write it as a product. So this will be the log base 5 of y to the 20th plus the log base 5 of z to the 18th. Right, now to condense, log base 5, it's plus, so it is a product, y to the 20th, z to the 18th. Alright, so we have 4 log of 4 plus 4 log of x. Alright, and so we're going to put this 4 back on. It is an exponent. So we have the log of 4 to the 4th. And this one goes back on. Is the log of x to the 4th. Now, you're not going to clean this piece up because this 4 is not the base. It was a 4 to the 4. It's log base 10. So I think they're trying to see if you get caught with that. You're actually just going to work this out. 4 to the 4th is, it's trying to say 64, but I don't think that's right. 4 to the 4th is 256. So this is log, and this is going to be a product. 256 x to the 4th. We can put that one down here. they will want you to put this one back as a root. All right, so it's down front. It is going to be an exponent. So this will be the natural log of z to the 1/3, which is the cube root. So the natural log of the cube root of z. This one you have to watch the problem, the parentheses here after the 6, that is around this whole thing. So this 6 is going to go to the outside of this piece when you put it together. So I have 6 times log base 5 of 7 plus the log base 5 of z minus the log base 5 of 2. All right, so this is going to have a product and a quotient, so this will be on the denominator. This will be on the numerator. I'm going to go ahead and work from the inside out because I can put these two together. And so this is log base 5 of 7z and the 6 is going to go back on here. So I have the log base 5 of 7z to the 6th minus the log base 5 of 2. All right, and now I'll deal with the quotient. So I write the log one time. This piece will go on the numerator. Over 2. Any question there? All right. 23 I skipped. I think that's pretty easy. 24 looks scary. Yes, question?
Sorry, yes, quick question. So if I wanted to, could I have put that 6 in front? I mean, I guess it would be longer to work out, but like the way that I saw it before you started working out was, oh, let's put the 6 in front of both of the logs, the addition ones.
To distribute it? You could.
Yeah.
You could do that. There's nothing wrong with that step. That's a legal step. And then it would be on each one, so it would go back to the exponent of each one. And so it would also be acceptable if you had the 6 down on each one. It should accept that answer also.
Okay, would that wouldn't have set me to a bigger number to this, like instead of 7, it wouldn't have been the 6. That's,
it would have been, the 6 here applies to both. And if you worked it the other way, it would apply to both. So it probably would accept 7 to the 6th. Otherwise, it is a very big number.
That's what I was wondering. It would be a bigger number of z to the 6th instead of the 7. That's where I was getting a little confused. But
I think you could do it either way. I think it would accept both.
Okay, perfect. Thank you.
You're welcome. And that's a very good question with these. A lot of times there's more than one way to start on these problems. As long as you're using all the right rules, you should still get to the same answer. Right, let's look at 24. This one just looks a little scary because that base is a fraction, I think. But it's really not hard. And so there's no exponents to put back on. This is a sum of logs, so it's going to be the log of a product. So x times x minus 10. I think that answer also would be okay. They actually, under the key, wanted you to distribute that out. But I will look and see if they will take that one. So what they wanted was you to distribute it out, x squared minus 10x. Okay, but we'll put it in the first way and see if they're okay with that. And that way also I'm typing in a log. So I could go under functions and it will give me log. And it gives me the one with the little box down here. All right. And in that little box, I need a fraction. So I can either type a fraction button or I can do 8 divided by 5 on the keyboard, and that should make it a fraction. All right, we'll try it that way. So I'm using keyboard, and that worked. Okay, now we have to get out of there, so I had to click, and I'm going to type in this one up here and see if it screams about that. Whoops. Okay, I wasn't done yet. Hit something. I must have touched the enter button on my keyboard. All right, now I have to have 2 parentheses, and it filled the other one in. So let's see if it likes that or if it wants it multiplied out. It wants it multiplied out. Okay, so it did not let me leave it here. So multiply it out. But you did see where I got that log button with the base. I went under functions. Let's see if it would give me a new question. I just wanted to show you again. All right, it's not get a similar question. Okay. All right, and so this one, just to show you how it's going to go back together, it was under functions. That's how you get the log with that down below. So log, and to get the space here, then I put 4/3, so 4 divided by 3, or you could use the function button. This is a product, but they're going to want it put back together. They're going to want me to do a parentheses, and so it will be x squared minus 2x. All right, and then I just want to go back on basic. And it wants me to put a parentheses there. Okay. So that is how to type it in. And our last one, we use something different. And this uses our change of base formula. If you watch the other video where I did these, I don't like to memorize that formula. There's way too many letters in it for me. When you're going to do change of base, except for one of these problems sends you to a different base, sends you to base 3. But basically when you change the base, you want to change to either base 10 or to base E. All right? And they are going to tell you which one to do. You want to change to those because that's what's in your calculator. All right. So let's just write a letter here. So if I have a log base b of x. Right. The way I like to remember these, so it's going to make a fraction. The one that is higher up, right? So not necessarily a bigger number, but this one, that's higher. The base is down low. So the base is going to go on the bottom, right? So we're going to take the log of x, now we're working base 10, over the log of this one that's down low. And to me, that is much easier to remember than writing the bases on there of what you want to get. That's just too many things. Okay. So maybe Miss H doesn't have much memory space. All right.
So the bottom number, so it's, I guess, a lot of them are log Bs, so bottom number B. I guess bottom, yeah, right?
Well, they're going to put numbers in all of these. So it's going to be the log, and
Yeah.
it's going to have a base here. So they
Okay.
actually are going to want you to calculate this out. And your regular log button won't calculate this. So you have to
But it
change the
doesn't-
base to do it.
Okay, but it doesn't matter, like the size of the number, it's just at that, the bottom number goes on the bottom always?
Always. Yes.
Okay, thank you.
Yes, with that formula. Any other question here? All right, let's work these problems. First we have log base 8 of 11. And they want us to rewrite it, and their directions were write it as base 10. So we will change this, and we're going to convert it to base 10. All right, so it is this number that is higher up, that goes on top. So the log of 11 over the log of the one that's down low. Right, and that I'm able to do in my calculator because those are both base 10. So that's what they want you to do for the second. So it's the log of 11 over the log of 8. All right, and then now they want me to get a number for that, and then they tell me to round to 4 decimal places. So I'm going to pull my calculator and turn it on, clear. And I'm going to do log, so I'm using common log of 11, right, divided by log of 8, enter. Right, and so I have 1.15314. I need to see this fifth digit because they want me to round to 4. If this was 5 or higher, I would go up. It is not, so we'll drop it off, and our answer will be 1.1531. All right, let's get a...
And that first one would be log 11 over log 8, the first answer in there?
Yes.
The log 8, okay.
Yes, they want you to actually show that.
Okay, yeah, I did it, but it was a couple days ago and my brain doesn't.
Okay. You're doing pretty good. All right. And this one, their directions are go to base E. I do see students miss this sometimes. So watch out for what they're asking for. So we're starting with log base 13 of 3, and they want us to go to base E. So when we rewrite it, we're going to use natural log of 3 over natural log of 13. Yeah, we're good. Mrs. H is terrible about remembering these parentheses. It will say syntax error, or it will put them on there to help me. All right, and so now let's go to our calculator. And we're going to clear. We're going to use the natural log button this time. Natural log of 3, and we have to close, divided by natural log of 13, close, enter. So this is 0.42831, and you want 4 positions, so you look to the right. A 1 you're going to drop off. 5 or higher you would go up. So 0.4283. All right. I better get a new sheet for this one. So this one's going to take more steps. All right, and they want us to change from base 6 to base 3. So the first step is going to be easy. It is going to be the log of 10, and we're going base 3 here, over the log base 3 of 6. This went on top, this went down here. But that doesn't help us as far as calculating. But that's the answer they want. And you could do your parentheses to make it proper. All right, so to calculate that, I changed each of these into log base 10. So I ended up with a complex fraction. So I worked just on the numerator and did it to base 10. So to get to the next answer, from here I'm going to base 10 so I can get it on my calculator. So this one is log of 10 over log of 3 over, and this is log of 6 over log of 3. And now these are base 10. So to punch that in my calculator, if I'm very careful with parentheses, I could do this whole thing divided by this whole thing. Or I can do some algebra, whichever one I want, and I'll try to show you both. So I'll show you the algebra, right? So we can write it across as divide. Remember, division changes to multiplication, and you invert the divisor. First fraction stays the same. And in multiplication, you can divide out common factors on the diagonals. So this gives me log of 10 over log of 6. Right? So I'm going to go ahead and put that in the calculator, and then I'm going to backtrack and just put this one in the calculator without this extra algebra. All right, so if I do this last one, I am just doing a log of 10 divided by log of 6. Enter. So I am getting 1.28509. 9 is going to push us up. So 1.2851. All right, so I'm going to go back and do this one just straight into the calculator. And you just need to use parentheses on the whole one that's on the top and the parentheses on the whole one that's on the bottom. All right, so I have parentheses. Log 10, close this for the thing that the end of the log, all right, and this is divided by log of 3, close, and now you have to close for the whole numerator. right, divided by, your whole denominator has to be in a parentheses. So log base 6, close for that, divided by log of 3. Sorry, it was not log base 6, it was log of 6. Close, and then you have to close for the whole denominator, and we should get the same answer, which we did. So, different approaches. We did everything legal both ways. Doesn't matter to me which way you choose, so you can do either way. And we'll get this out of the way and check the answer. And so the first answer, I think we looked at it, this is what they wanted. So this first piece. And then there is our approximation. Any question there? All right, that is the end of our exercise set. So I'm gonna stop a little bit early today. Anybody have questions? There was one more thing I wanted to tell you guys. I don't have a template to show you, but if you have a TI-84 calculator, you can find the log of a different base. Now you would still have to know how to do change a base because it's requiring this first step. It's requiring you to show what you did. But on this calculator, if you have the TI-84 plus, any of those versions, under the math menu, and you have to go all the way to the bottom, and it goes on down past 9, 10, and then it's A. So you go down, scroll down, and it's A, which is log and base. Looks like that. And it will allow you, if you choose that one, to put in a different base and calculate it. But you can't do it on the TI-83. So anyway, you can explore that if you have that. You still need to know this change of base formula to be able to do this first piece, and you should know it, but anyway, I did want to show you that. So you can use all the things your calculator has. Yes?
I believe Desmos, because when I was putting log into, I mean, I have a calculator, but my eyes are. Anyway, when I use Desmos for things, I feel like it allows me to put a particular log in.
It might.
For the calculator.
I haven't played with that feature of it.
Yeah, I'm pretty sure it allowed me to do that.
Okay. All right, very good. So that's something you guys can explore on your own, but I can't show you because I don't have a template for that calculator. All right, you guys have an awesome day. There's only 2 sections left. This semester's going to end really fast, so make sure you are all caught up. And the next 2, they're real important. One is equations and one is applications. The applications will take you a little while to do those. So make sure you're all caught up. All right. You guys have an awesome day.
Thank you, Professor. Thank you, Professor.
You're welcome. Thanks for
Are the
coming.
applications 5.4?